So we will be handling power electronics and drives. Okay, in power electronics and drives, we will be studying about the all electronic devices, very small devices. Okay, switching devices. Switching devices means you should know that switching devices are made up of what type of material? Semiconductor materials. Okay, we have been might study in school that is semiconductor materials like silicon or germanium. You will be most probably using those two materials. Okay, silicon of what voltage rating? Do you know that? What is called silicon and what is called germanium? Most probably or most frequently we will be using these two semiconductors. That is silicon or else we will be using germanium. Okay. So using these materials, we are going to make a switch with the two conduction, like two terminals. Sometimes just three terminals. Okay. So based on the terminals, we are going to have the switch as name DB also. So if we are taking silicon, it will range up to 0.71. When we are taking it for germanium, it is 0.92. Okay. So that is the rate. We will be saying that is ratings of that particular material semiconducting devices. That is with the silicon 0.7, this germanium 0.9. And what we are going to do with these materials? Okay, mostly other semiconductor materials is also available there, but we are using most probably these two materials. Okay, so here we are saying that as unit 1 we will be studying about controlled rectifier. So rectifier means what do you know? It is a rectifier means what it does mean? Rectifier. So as a AAA or as an electronic electrical engineer, you should know this rectifier means it's a converter. Okay, rectifier that converts AC to DC. Rectifier that converts AC to DC voltage or something. Okay. So for converting AC voltage to DC voltage, we will be going for the device that is called rectifier. Okay. So here one more word is that is controlled rectifier. So what you are going to do? You are going to control it according to your need. If you want to, if you are converting an AC supply to DC supply, it is default. While we are converting, it is default. What amount of voltage we are giving as an input, it is going to convert as output. If I want to control it, means what I will do in the conversion circuit, I will be adding some more devices, or we can say some more switches to control what we are going to do. I want to switch to on or off this fan. I can to control this one. I am now switching off the and owning it. If I on it, it will run. Right? So that is the condition. So in the conversion circuit, if I am going to add a switch, then I can able to control it. Right? So that is the controlled rectifier. So now I am saying I am going to add the switch. Right? So that switches are the switching devices. That switching devices are made up of these semiconductor materials. So now, first I am saying that switching, right? So first device, what you will be studying about means that is power diode. The first device you will be studying about that power diode. You have heard this name, diode rectifier. Okay, or power diode. Power diode means you will be having. Did you remember this? What it is? It is the symbol of the diode. Okay, so this is a symbol of the diode with the terminals anode and cathode. Okay, so the first material for the controlled rectifier, the first device which you are studying is power diode, and this power diode which has a symbol like this, and it will having two terminals, that is anode and cathode. Okay, there are various specifications are there in the power diode. In lab, we will be using, or in frequently, if you see any of the electronic devices. Okay, if like a remote controlled car. Okay, so what you will be doing is, you don't need to take a car itself. There is no conventional facilities. We can take any TV. Okay, so what is there for? It is built with electronic devices, right? If you take it there will be a conversion circuit. Okay. that they will be using this diode rectifier, or in many applications, or most probably the diode specifications will be IN4007. Other specifications of diode is also available, but mostly they will be using this specification of diode for lab as well as and for mostly in other electronic devices. Okay, so wherever I need to convert the AC supply to DC, I will be using for diode rectifier. Okay, and this diode rectifier will convert AC to DC. Now you know. So what I am going to do is I am going to the AC supply. Okay. So to a diode. So what I am going to give us an input is AC supply, which means phase neutral. Okay. So here it is going to be my output voltage. Okay. So if I straightly give like this means, what about my diode? If my AC voltage is fluctuations, what happens? My diode will damage, right? So what we will be doing? I will be connecting a to limit the current. I want to connect a resistor. Okay. So I will be connecting a resistor to it. Okay, so if I want to convert this AC to DC, or else we can connect in this way. Okay, so rectifier, two modes of operation. Okay, if this is phase and this is neutral, means it will become reverse bias condition, right? So we can draw this. Anode, cathode. So phase to anode, it will be forward bias condition. Okay, so now I will tell you that. Okay, I will tell you that forward bias, reverse bias condition on that. But basically, what you want to know is this conversion. So what is happening when you are giving an AC as an input? What is like it is converting as DC. To limit the current for that purpose, I am adding a resistor to it. Okay, so this rectifier circuit is said to be the diode rectifier. Okay, and so now we know that diode has a two terminals, one is anode and other is cathode, and we know the specification for it. Likewise, so where we are applying this diode? Can you give me some application example? Small application example. I studied hardware rectifier. You studied it?
School level.
Okay, okay. Now tell me where they are applying it, diode rectifier.
Electronic devices.
Mostly probably that one has a specified application means one specified application for diode rectifier means
Cell phones.
okay, I will tell you. Okay. In serial bus. Okay. In serial bus, you might have seen that after connecting to the plate, a small box will be there. Did you notice that? After that only your bulb filters will be there, which is connected in series. Right? Am I right? Once connected to the plug, okay, so it's going to be a small box. Inside the box, what it will be there means you will be seeing that the rectifier circuit will be there. That is, okay, diodes are connected. If you notice that, the diode will be connected like this. The diode will be connected like this. Okay. So here is your input AC supply, and by then we will be having the not this one. By then we will be having the DC supply. Okay. So this diode rectifier rectifier circuit will be say connected in like this way, right? One after the other. Okay. So this is said to be the bridge diode rectifier. Okay. So in every serial bulb, if you open that box, inside that you can see the diodes. The diodes are connected in this way. Why they are using 4 diodes means actually what we normally for serial bulb we have multiple bulbs has to do, right? So initially we are taking a 230 volt, right? So to make us serial bulbs to go low, do we need 230 volt? So what we will be doing? First we have to step down it. Okay. So we will be using a step down transformer. I will show you that. Okay. So I told you, right? So here we are giving a input AC supply. So this is 230 volt. Okay. So 230 volt means you will be having a small transformer. Okay. So if you note down here, we will be writing it as 9 volt. 9 volt 09 volt. Like when the small transformer are available, 12 volt is available, 24 volt is available, whatever for our requirement based on the electric devices which we are going to operate based on the transformer ratings are available. So whenever we are giving this AC input, what is the function of the step down transformer? It will step down. You know that the conception of step down transformer. The primary windings are greater than the secondary winding. So based on the number of turns, it is going to transfer the electrical voltage. It will what it will do? It will step down the electrical voltage. So yeah, from the output of this, okay. Now here we will be getting the output from the transformer. Okay. So here the phase neutral. This is what AC only. Okay, just we are stepping down the AC voltage. That is from 230 volt we have stepping down into 9 volt. If it is a 9 volt means 9. If you notice that here we have written as 9 volt 0 9 volt. So it is stepping down to 9 volt AC. Okay. So from here also we will be taking a phase neutral of 9 volt. Okay. So after that we will be connecting rectifier, that is diode. Okay. So from here on to the next what we are going to do? We are going to connect this. We will be giving it in breadboard. Okay. So after giving to breadboard means we will be connecting to breadboard the diode along with the resistor. For what purpose the resistor is? To limit the current. Okay. Because there won't be any damage for the diode. So to limit this current, we will be connecting the resistance in series to it. Okay. So after that what happens? This diode will convert the particular AC to DC. That is how the diode rectifier will work. Okay. So now you have to write down the principle of operations of this diode. Actually, this is the concept. What it is doing. Okay. For writing the principle of operations of the diode, you must know the forward bias and reverse bias condition. Okay. So this is how, as I said, for the serial bulb circuit application also, what it will do is using the bridge diode rectifier. Anyways, an AC supply that is connected to the diode means it will convert it into DC. Okay. So with that supply DC only, what it is doing? The serial bulbs are glowing. Right. So now. So now listen. Diode of two. One is forward bias from anode to cathode. Okay. So the other is from cathode to anode. So this is forward bias condition. Okay. This is reverse bias condition. Okay. So for that also we will be studying here VA characteristics of it. Mostly we will be using, we will study this in school. P type semiconductor, N type semiconductor. So we can say that PN junction diode. Mostly we will be using this. Then P type semiconductor. Okay, is in junction with the N type semiconductor. In between who is there? Depletion layer. Okay, in between there will be depletion layer is there. Okay, so this is P type, or you can say this P type, and this is the terminal anode, and this is the N type, and you can say the terminal as yes. So this is how PN junction diode with the junction depletion delay. Okay, and now two modes of operation will be there. Okay, first is forward bias conversion. Okay, so the diode is going to be forward bias. Okay, so I am going to experimental setup. I am going for a battery. For the experimental setup, what we are going? I am going for a battery. Battery means we can say that regulated power supply. Okay, I can vary the voltage up to 0 to 30. Next, what will be there? Resistor will be there. After that, what will be there? Diode. If this positive is connected to anode, means that is positive is connected to anode, means that is no. That's it. So, here will be our output voltage, and this is cathode. So this is the forward bias diode function. So now, what we will be doing? Input as an input, we will be giving a DC. For experimental purpose, I have changed it. That is application oriented. Where we are using, why we are going for diode rectifier. For that purpose, I explained that. Okay, so experimentally, study the diode rectifier. Diode rectifier மட்டும் பத்தி படிக்கிறதுக்கு we will be experimental setup use பண்ணா படிப்போம். That experimental setup we are giving a DC. நான் அது வந்து ஒரு application oriented சொன்னேன். Diode rectifier எங்க மேம் யூஸ் பண்ணாங்க அப்படி கேக்கும்போது application oriented நீ டிவி பார்த்த அப்படினா we are giving input as DC. DC. Yes. டிவி பிளக் எங்க கொடுக்கிறோம்? AC supply. Okay, but உள்ள இருக்கிற electronic devices items எல்லாம் நம்ம பார்க்க முடியும். உள்ள வந்து chip boards இருக்கும். boardsல என்ன இருக்கும்? சின்ன சின்ன electronic devices இருக்குமா? capacitors இருக்கும், diodes இருக்கும். Okay, or else other electronic small devices will be there. Everything will act in DC. Okay, எல்லாத்துக்குமே voltage ratings எவ்வளோ? ரொம்ப minor. Okay, for that we are going for that particular devices. For that we are going for that diode rectifier. Application இங்க அவங்க சொன்னதுதான் AC. அதை நான் step down பண்ணிக்கிறேன் using a step down transformer, and by using a diode rectifier I am converting it. Okay va? So diode rectifier operation, whenever you are studying about specifically and want to know the operation of the diode rectifier, means I will be going for the experimental circuit, not with the AC. AC வச்சு நம்ம டெஸ்ட் பண்ண மாட்டோம். AC வச்சு ஏன் பண்ண முடியாது? We have to further stepping down of voltage. Okay, இங்க என்ன பண்ணிக்கலாம்? DC voltage நம்ம கொடுத்துக்கலாம். 30 voltage நம்ம ஃபிக்ஸடா, so அது diode rectifier எந்த voltage rating ல ஆட் ஆகுமா, that minimum value of voltage I can able to provide, right? So that is for a reason we are going for a DC. Okay, so I am giving a DC supply, regulated DC power supply of rating 0 to 30 volt. I can vary it up to 30 volt. I am connecting a resistance of any value. Most probably you can choose it at 1 kilo ohm or 100 volt. Okay, between that very particular ranges. Next to is the diode. Okay, so the positive terminal that is connected to the anode, it is forward bias. Later on it will be decreased. Movement of current. Okay, so either at that point so what will happen means we will be seeing that as a characteristics. Voltage with respect to current. Okay, so this is during forward bias. This first quadrant we will be saying this is first quadrant, right? So this first quadrant will be seen as a forward bias, and this is that quadrant we will be marking for the reverse bias. Okay, so how the conduction of the diode will be? Once the voltage is given, what is going to happen? We have to explain this diagram. Okay, once positive terminal is connected to the anode and the negative terminal is connected to the cathode. what will happen means here who is going to be there means holes. In P type junction who is going to be there? Holes. And in N type electrons will be there. And in N type who is going to be there? Electrons will be there. What will happen means when the positive terminal is connected to the anode is connected to the positive terminal and when the cathode is connected to the negative terminal, the holes from the P type semiconductor and the electrons from the N type semiconductor will move towards the depletion region. That is why I write the operation. What will happen? What you have to say? When the and the cathode is connected to the negative terminal, the holes from the P-type semiconductor and the electrons from the N-type semiconductor. Why it is electron? Negative electrons is N-type semiconductor. Okay, in P-type semiconductor there will be holes. Okay, both will be moved towards the depletion region. So, what will happen? The depletion region will become narrow, slower. Okay, so in the depletion region is lower means what will happen? The conduction starts. Okay, so based on the voltage we are applying. Okay, based on the voltage we are applying, how the current. So if voltage increases automatically, current increases. This is how. That is the forward bias of the PN junction, or we can say the forward bias of the diode. Okay. So the next is reverse bias. For reverse bias, anode is connected to the negative terminal, cathode is connected to the positive terminal. And likewise here also the same. Okay, anode is connected to the negative terminal and cathode is connected to the positive terminal. So during this time, what will happen is the holes from the P-type semiconductor, will move away from the P-type semiconductor, and the electrons from the N-type semiconductor will move away from the depletion region. What you have to say? The anode is connected to the negative terminal, cathode is connected to the positive terminal. During this reverse bias condition, what is happening? The holes from the P-type semiconductor move away from the depletion region. Likewise, electrons from the N-type semiconductor moves away from the depletion region. So, what about the depletion region then? Broader, or we can say that is wider, higher in width. So, at that time, what will be happening means it will basically, while the conduction during the positive of cycles, there will be some leakages, right? So, up to particular point, it will increase. Here, because small arrow, that is usually followed by a leakage. Okay. After that, what will happen means during reverse bias, there will be no increase of current. Here is also the same voltage, and this is current in reverse bias, voltage in reverse bias, this is voltage in forward bias, this is current in forward bias. Okay, so what will happen? Initially, due to some forward bias leakage condition, it will increase for some period. After that, there won't be any increase in current. After that second period, what will happen means it will occurs a breakdown. There occurs a what? Breakdown. Okay. So beyond that, what will happen means the current will increase drastically. The voltage changes. Okay. This is how the operation of the diode will be. What you have to say means during the reverse bias condition, with respect to the voltage, the current will remain same for some period of time. It won't change. After particular voltage rating, this voltage, particular voltage breakdown. Okay. That breakdown period of that particular voltage is said to be breakdown voltage. that voltage and the breakdown attain on the time level, your current will get drastically reduced, but your voltage won't change. In RPS we will be seeing it as an experiment also. Okay, in regulated power supply, if you take the input RPS 0 to 30 volt, in 15 volt if it is getting breakdown means if you are still increasing 16, 17, 18, still you are increasing, but what it will do means the voltage whatever you can increase, but it won't, the current will increase. So, but the voltage cannot be changed. Okay, you can't be changed the voltage. That it will be fixed. Okay, and here it is increases, it increases. Okay, this is the characteristics of the diode. Okay, no. So next switching device is the SCR. Okay, SCR is again a control rectifier. Full form of SCR will be saying it as silicon control rectifier. Okay, this is the initial name of the switch. Okay, later on it is called as thyristor. Shorter later on we can thyristor. Okay, so silicon control rectifier SCR later on will be called as thyristor. So this is a 4-layered device. Okay, 4-layered switching device. So when we are saying it is 4-layered means what we have seen with the diode, semiconductor dividers of P type and N type. So here one more P type and N type is going to be there, like P type, again the N type, again a P type, again a N type. Okay, with this PN junctions. Okay, so 4-layered means how many junctions will be there? J1, J2, 3 junctions. Okay, 4-layered, 3 junction terminals also for P. Okay, for this P, that is we will be having anode as a terminal and this N-type semiconductor will be having a cathode as a terminal and the middle junction J2. Okay, it is going to be having as a gate as a terminal. Okay, so this will be same in the construction part. So silicon control rectifier, here this is a semiconductor switching device. We are going for semiconductor switching device. I have told in the last class, that is to control any electronic operations. Okay, so in case of switching on or mode, controlling rectifier circuit. Okay, so in that we are seeing SCR, later on it is called as thyristor, having 4 layers, PN, TN. Like these are the layers, P type semiconductor, again in N type, again in P type and again in N type semiconductor, having 3 junctions, J1, J2, J3 as junctions and 3 terminals, anode, cathode. Along with that, gate is going to be there. First we have seen the diode. In diode we have seen 2 terminals, anode and cathode. Okay, while in SCR, 1 more terminal is going to be anode and that it is gate. Okay, so what we are going to see is next the symbol of the SCR. So when we are talking about the symbol of the SCR, same as like that of the diode, because here is 2 terminal, that is anode and cathode will be there. Along with this, who is going to be there? Gate. That is what the symbol of the SCR or thyristor. Okay, so now SCR anode to cathode will be the forward conduction. Right? So we can say that this SCR is an unidirectional device. This SCR is what device? It is unidirectional. When we are talking about SCR, it is a unidirectional device, which means it can conduct only from anode to cathode. That particular point, that forward conduction mode only, the switch will be in the on condition. The rest of the mode of region of operations, it will be in the off condition. Okay, so when we are going for the, now we know the symbol of it. Okay, so how will we connecting for forward bias? We are using an RPS, that is plus minus DC voltage. In resistance will be connected in series. Okay, one more point I have to add in the construction, that When the SCR will turn on means it will be turn on when the positive voltage is given to anode and gate. Sorry, gate and cathode. Okay. When the SCR will turn off, when it is the positive voltage is given between gate and cathode. Whenever the positive voltage is given between the gate terminal and the cathode terminal, it is going to on SCR. Okay. And now, as I said before, positive will be given to the gate. Right? So, gate is going to be like this. Okay. So, I will draw over there. Because I have to draw the SCR. So I am giving positive. With that, for limiting the current, I am connecting a resistance in series. After the positive terminal, I am going to give it to the gate. Who is going to be there?
Gate. Cathode.
SCR is going to be there. And between two, whom I am going to connect to the voltage source? Positive as well as gate as well as cathode. Could you remember this point now? Voltage is applied between the gate as well as cathode. Whenever positive voltage is applied between the gate and the cathode, the SCR will
Turn on.
Okay, so this is the terminal called anode. And now, again for the output side, we will be getting the current, we will be connecting a resistor over there. If this is R1 and this is R2, across which we will be seeing the output voltage. Clear? This is the circuit diagram for determining the characteristics of SCR. Okay, so the same for reverse bias, what you have to do? Just you have to raise the positive as well as negative. Okay, or else you have to reverse the switch, which is easier because the input is easier. Okay, so one more thing is for two biasing mode of connection will be there. Okay, so either the other is instead of measuring the output voltage, okay, for the other mode of operation, we will be having a input voltage supply towards the other side also. Okay, so we will be having two RPS over here as well as RPS over this side. Okay, for the two mode of operation, I will be telling you here there is three mode of operation will happen in the SCR. Since there is two terminal, not just from anode to cathode, cathode to anode. In diode, we have seen that our conduction mode is either forward bias and reverse bias. That is as anode to cathode, forward bias. If we change the terminals, input terminals, means it will be from cathode, it will get reverse. Here, one more terminal is that is gate. Okay, based on that also it has to act, right? So, how many modes of operation will be? Means there are three modes of operation over here. So, while seeing that, first, just take a note of it. So, when we are talking about the operation of this SCR, okay, so there is first forward blocking mode. Three modes of operation. The first is forward blocking mode, and the second one is forward conduction mode. Forward conduction mode. Okay, and the third is reverse blocking mode. Okay, so based on this, as like that, diode எப்படி நம்ம பார்த்தோமோ அதே மாதிரி இருக்கும். VI characteristics both in the reverse bias condition as well as in the forward bias condition. Okay, initially forward blocking mode. Same here, the positive terminal is given to the gate and cathode, like this is one side. Okay, so when we are saying from this side, positive is connected to the anode and negative is connected to the cathode. So this circuit we are going to explain. Okay, that is for forward blocking, okay, forward blocking. So when positive is connected to the anode, and the negative is connected to the cathode. The positive is connected to the anode, and the negative is connected to the cathode. During this process, who is going to act? It is going to act as a diode, right? Because in diode also anode is connected to positive, cathode is connected to negative. But what is the difference here? There is only one p-type and one n-type. Here, how many p-types and n-types are there? It is 4 layers, right? So 3 junctions are there. So during this connection mode, what will happen means, see, these 3 junctions. More junctions are there. So that is Pn, and we are saying this is positive. This is connected to positive, right? And this cathode terminal is connected to the negative. So during this period, this junction J1 and J2. Junction J1 and J2. So if you see that the current flow, how it will be towards this side, right? Pn, anode to cathode only, no, because anode is connected to positive, cathode is connected to negative. So this is the way it will flow, correct? So positive Pn, when you are taking this junction J1 will be in the conduction stage. Okay, or we can say that it will be in the on stage. Okay, whereas when you are considering the junction J2, how it is N2P. N2P means the cases in diode N2P means reverse. That's it. Okay, in junction J2 is reverse bias condition. And what about again junction J3? P2N, which is forward bias. So you have to mention that this junction J1 and J2 are in the forward bias condition, and in the junction J2 is in the reverse bias condition. So whenever p-type semiconductor is connected to the anode, there is positive terminal is connected to the anode, and the negative terminal is connected to the cathode of the SCR. What is happening? Junction J1 and J3 are in the forward bias, and junction J2 is in the reverse bias. Okay, until when it continues means, so if you see sometimes this P to N is flowing, again N to P it will be flowing, again P to N it will be flowing. Okay, anyhow the current is now filled with these all 4 layers, right? So due to this, during the cycle of conduction, what will happen means there will be some small amount of leakage current. Okay, there will be some small amount of leakage current. So due to that small amount of leakage current, the current will flow in this direction also. That is from P to N. என்ன சொல்றேன் 4 லேயர்ல இருக்குறதுனால what is happening Pn junction J1 and J3 is from the forward condition. Okay, J2 என்ன ஆகுது நமக்கு NP எப்படி இருக்குன்னா ரிவர்ஸ்ல இருக்கு. But cycle of conduction until it carrying some amount of flow of current, right? So due to that reason, what is happening? So some small amount of leakage current is there in these 4 layers. So due to that reason, what is happening? The current is flowing from the P to N in case of J2 junction. So because of that, J2 now what does happen means it occurs a breakover voltage. Okay, there occurs what? Breakover voltage, or we can say that the minimum voltage where the junction J2 start to conduct. The minimum voltage when the junction J2 start to conduct, that voltage is said to be breakover voltage. Okay, so when we are drawing this as here, starting initially when voltage increases, current increases. After some period of time, there will be some reverse blocking stage. Okay, so up to this, what is happening? Up to this, the forward blocking region, or we can say up to this, the forward blocking mode. Okay, after that, what happens means we are going to give a gate pulse. We are going to give a positive voltage. Okay, after the what it is happening, the SCR is obtaining the positive voltage from the for the gate terminal. Now anode is positive, cathode is negative, gate is also gaining a positive voltage. By that, what will happen means this process will get reversed. Okay, that is junction. What will happen means, so this is now maintaining some amount of as I said, breakover voltage. Till here, this is the breakover voltage. Okay. After that, what will happen means it will hold that particular value of voltage up to some extent. After a particular period, what will happen means it will increases drastically. Okay. After certain period of time only. After holding current means the minimum value of current when this breakover voltage during the minimum value of current when the breakover voltage attain that particular current is said to be holding current. எப்போ பிரேக் ஓவர் உனக்கு அட்டைன் ஆகுதோ அந்த வோல்டேஜ் என்னன்னு சொல்லுவோம் பிரேக் ஓவர் வோல்டேஜ்னு சொல்லுவோம். எந்த வோல்டேஜ்ல அது அக்கர் ஆகிட்டு கொஞ்சம் நேரம் எந்த சேஞ்சஸுமே இல்லாம கரண்ட் இருக்குதோ அந்த கரண்ட்டை தான் என்னன்னு சொல்லுவோம் அப்படின்னா ஹோல்டிங் கரண்ட்னு சொல்லுவோம். இது லேப்ல செய்யும்போது தெரியும் வோல்டேஜ் வந்து 1 3 5 7 இன்க்ரீஸ் பண்ணிட்டே வரும்போது உனக்கு என்ன ஆகும் அப்படின்னா கரண்ட் இன்க்ரீஸ் ஆகிட்டே இருக்கும். ஒரு பர்டிகுலர் பீரியட்க்கு அப்புறம் வோல்டேஜ் எந்த சேஞ்சஸுமே காட்டாது. 7 வந்துச்சுன்னா 7 7 7 7 மட்டும் தான் இருக்கும். கரண்ட் மட்டும் என்ன ஆகிட்டே இருக்கும் அப்படின்னா உனக்கு இன்க்ரீஸ் ஆகிட்டே இருக்கும். ஓகேவா? ஸோ சர்டன் பீரியட் ஆஃப் டைம்ல உனக்கு அந்த வோல்டேஜ் இப்போ என்ன ஆயிடுச்சு பிரேக் ஓவர் வோல்டேஜ் அட்டைன் ஆச்சு. ஒரு ஷார்ட் பீரியட் ஆஃப் டைம்ல கரண்ட் உனக்கு எப்படி இருக்கும் அப்படின்னா ஒரே வேல்யூஸ் காட்டும். 3.2 னா 3.2 3.2 3.2 காட்டும். that current is said to be holding current. புரிஞ்சுதா உங்களுக்கு? ஸோ இதுதான் என்னது அப்படின்னா உனக்கு ஃபார்வர்ட் பிளாக்கிங் மோட். அதுல இருந்து உனக்கு நெக்ஸ்ட் என்ன ஆகுது ஃபார்வர்ட் கண்டக்ஷன் மோடுக்கு உனக்கு மூவ் ஆயிடுச்சு. நெக்ஸ்ட் இஸ் தி ஃபார்வர்ட் next is the reverse blocking mode. So this reverse blocking mode is same as that of the p-n junction diode. Now diode பார்த்தோம் இல்லையா அதே மாதிரி இப்போ இங்க என்ன பண்ண போறோம் அப்படின்னா we are going to revise the supply. Positive is going to be as negative, negative is going to be as positive, which means anode is connected to negative terminal, cathode is going to be connected to the positive terminal. So இந்த ஆபரேஷன் அப்ப என்ன ஆகும் அப்படியே ரிவர்ஸ் ஆகும். அப்படியே ரிவர்ஸ் ஆச்சுன்னா H2 junction is going to be forward and which junction is going to be reverse?
J2 is forward.
J2 will be in the forward condition, J1 and J3 will be in the reverse condition. So during this condition அந்த மாதிரி இருக்கும்போது இப்போ J1 J3 ரிவர்ஸ்ல இருக்கும்போது ஏதாவது ஸ்விட்ச் ஆன் ஆகிறதுக்கு ஏதாவது சான்சஸ் இருக்கா? Because these both are in reverse. Only connection is the gate. Okay. So how we can able to completely turn off when only it will be in the on state means that is during the forward conduction mode. The forward conduction mode la mattum da அது எப்படி இருக்கும் அப்படினா on state ல இருக்கும். reverse conduction mode ல பார்த்தா எப்படி ஒரு diode நமக்கு இருக்குதோ அதே characteristics தான். இதே characteristics தான் diode க்கு பார்த்தோம். அதே characteristics தான் நம்ம reverse க்கு இருக்கும். forward ல மட்டும் ரெண்டு changes வருது. ஒன்னு forward blocking region, forward conduction region. S மாதிரி S ஓட upper half வந்து for conduction region, lower half வந்து forward reverse region. அதுல first attain ஆகுது break over voltage. ஓகேவா? அதுல மெயின்டெய்ன் ஆகுற கரண்ட் பேரு ஹோல்டிங் கரண்ட். சரி, அந்த break over attain ஆகுது இல்லையா அந்த பீரியட்ல ஒரு கரண்ட் வேல்யூ இருக்கும் இல்லையா அந்த கரண்ட் என்னன்னு சொல்றோம் அப்படின்னா latching current சொல்றோம். ஓகேவா? that is another law ஆகுது. Okay, so we will be saying that as latching current. Okay, நல்லா நோட் பண்ணிக்கோ, different terms மாதிரி படிக்கிறோம். ஓகேவா? that is நார்மலா ஒரு ஃபார்வர்ட் பிளாக்கிங் ஸ்டேஜ்ல நார்மலா இந்த சைடே வர கரண்ட் ஒரு பர்టిక్యులர் பீரியட்ல பிரேக் ஓவர் ஆகுது. அந்த பிரேக் ஓவர் கிடைக்கிற வோல்டேஜ் தான் என்னது பிரேக் ஓவர் வோல்டேஜ். அந்த பீரியட்ல இருக்கிற கரண்ட் தான் என்னது latching current. அதுக்கப்புறம் அது கொஞ்ச நேரம் சஸ்டெயின் ஆகும். that current is said to be the holding current. after that it start to conduct that particular point only the SCR will be in the on state. Other two mode of operation the SCR will be in the off state condition. It won't turn on. Okay, so now I am saying that forward conduction mode la mattum SCR எப்படி இருக்கும்னு சொன்னா on condition இருக்கும். அப்போ forward conduction mode எப்போ வரும்னு உங்களுக்கு தெரியுமா? நமக்கு என்ன தெரியும்? just ஆபரேஷன் கொடுத்த உடனே SCR கனெக்ட் ஆகுது. அது இன்டீரியரா நடக்கிற ஆபரேஷன். நம்ம பிரின்சிபல் ஆஃப் மோட் ஆஃப் ஆபரேஷன் ஒரு மோட் ஆஃப் ஆபரேஷன் நடக்கும்ல தனித்தனியா நடக்குமா? சப்ளை கொடுத்தல வந்தாஸ்ல அது நடக்குமா? it will happen automatically, right? So now அப்போ என்ன ஆகுது forward conduction mode ஒரு conduction start ஆயிடுச்சு. how to turn it off? அது எப்படி நம்ம turn off பண்ணனும் அப்படினா either by reducing this gate voltage. இந்த voltage என்ன பண்ணனும்? reduce பண்ணனும். அப்படி இல்லனா இந்த voltage என்ன பண்ணனும்? reverse பண்ணனும். These are the two methods to make the SCR turn off. Okay, either to make it or either to withdraw the gate voltage. Gate voltage stop பண்ணிடணும். அப்படி இல்லைன்னா anode cathode terminal கொடுக்குற voltage வந்து reverse பண்ணோம் அப்படின்னா நமக்கு என்ன ஆகும் அப்படின்னா we can able to turn off the SCR. Okay, so other mode of method of turning off the SCR என்னெல்லாம் உனக்கு அப்படின்னா dV by dt ன்னு சொல்லுவோம். SCR வந்து like mode of operation protect பண்றது வந்து some methods are there. Okay, thermal protection will be there, dV by dt protection will be there. Okay, later on we will be seeing on that. Now these are the characteristics of silicon controlled rectifier and its mode of operation along with the VA characteristics. So for any doubt here, SCR na enna first solana, it is a unidirectional device. Initially it is called as silicon controlled rectifier, later on it is called as thyristor. After that it is having 4 layered device, 3 junctional device, 3 terminal device. The 3 terminals are anode, cathode and gate. Apro positive half cycle. Anode is connected to the positive, cathode is connected to the negative. At that period, what will happen in reverse blocking condition. So reverse 3 modes of operation: reverse blocking mode, forward conduction mode, forward blocking mode, forward conduction mode, reverse blocking. So forward blocking will be explained in detail. J1 to J3 will be in the forward bias, J2 is in the reverse bias. So J2 reverse ஆகும்போது due to some small leakage current, J2 will be having a flow from the forward ஆகும்போது உனக்கு என்ன ஆகுது, அந்த இடத்துல break over voltage அட்டெண்ட் ஆகுது. At that particular break over voltage எங்க அட்டெண்ட் ஆகுதோ அந்த current latching current னு சொல்லுவோம். That will be sustained for certain period. That current will be said to be holding current. Okay, so later on adukapra enna panna porom appadina the SCR will in the forward conduction mode, that is normal mode of operation. And the stage la mattuna SCR will be in the on condition. After that reverse blocking condition is same as that of individual. Anode vandu negative, cathode vandu positive kudukumbodhu apdiye vandu reverse agradhunala there will be apdiye reverse. J2 will be in the forward bias, J1 J3 will be in the reverse bias condition. No mode of condition will be there. So during that period, SCR will be in the off condition. So on state during forward conduction or on state SCR, in order to turn it off, what you have to do? Only reduce the value of the gate voltage, or else we can reverse the voltage of the other terminals voltage. Okay. So after that, you have completely explained this switching mode of operation. You have to explain the VA characteristics also. That is all about SCR characteristics. So we will be handling power electronics and drives. Okay, in power electronics and drives, we will be studying about the all electronic devices, like small devices. Okay, switching devices. Switching devices means you should know that switching devices are made up of what type of material? Semiconductor materials. Okay, we have been might studied in school. That is semiconductor materials like silicon or germanium. You will be most probably using those two materials. Okay, silicon of what? Voltage rating. Do you know that? What is called silicon and what is called germanium? Most probably or most frequently we will be using these two semiconductors. That is silicon, or else we will be using germanium. Okay. So using these materials, we are going to make a switch with the two conduction, like two terminals, sometimes just 3 terminals. Okay. So based on the terminals, we are going to have the switch as name DB also. So if we are taking silicon, it will range up to 0.71. When we are taking it for germanium, it is 0.92. Okay. So that is the rate. We will be saying that is ratings of that particular material semiconducting devices. That is with the silicon 0.7, plus germanium 0.9. And what we are going to do with these materials? Okay, mostly other semiconductor materials is also available there, but we are using most probably these two materials. Okay, so we are saying that as unit 1 we will be studying about controlled rectifier. So rectifier means what do you know? It is a rectifier means what it is mean? Rectifier. So as a AAA or as an electronic electrical engineer, you should know this rectifier means it's a converter. Okay, rectifier that converts AC to DC. Rectifier converts AC to DC voltage or something. Okay. So for converting AC voltage to DC voltage, we will be going for the device that is called rectifier. Okay. So here one more word is that is controlled rectifier. So what you are going to do? You are going to control it according to your need. If you want to, if you are converting an AC supply to DC supply, it is default. While we are converting, it is default. What amount of voltage we are giving as an input, it is going to convert as output. If I want to control it, means what I will do in the conversion circuit, I will be adding some more devices, or we can say some more switches to control what we are going to do. I want to switch to on or off this fan. I can to control this one. I am switching off the and owning it. If I on it, it will run. Right? So that is the condition. So in the conversion circuit, if I am going to add a switch, then I can able to control it. Right? So that is the controlled rectifier. So now I am saying I am going to add the switch. Right? So that switches are the switching devices. That switching devices are made up of these semiconductor materials. So now, first I am saying that switching, right? So first device, what we will be studying about means that is power diode. The first device we will be studying about that power diode. You have heard this name, diode rectifier. Okay, or power diode. Power diode means we will be having. Did you remember this? What it is? It is the symbol of the diode. Okay, so this is the symbol of the diode with the terminals anode and cathode. Okay, so the first material for the controlled rectifier, the first device which you are studying is power diode, and this power diode which has a symbol like this, and it will having two terminals, that is anode and cathode. Okay, there are various specifications are there in the power diode. In lab, we will be using, or in frequently, if you see any of the electronic devices. Okay, if like a remote controlled car. Okay, so what you will be doing is, I don't need to take a car itself. There is no conversion of AC to DC. We can take any TV. Okay, so what is there for? It is built with electronic devices, right? If you take it there will be a conversion circuit. That they will be using this diode rectifier, or in many applications, or most probably the diode specifications will be IN4007. Other specifications of diode is also available, but mostly they will be using this specification of diode for lab as well as and for mostly in other electronic devices. Okay, so wherever I need to convert the AC supply to DC, I will be using for diode rectifier. Okay, and this diode rectifier will convert AC to DC. Now you know. So what I am going to do is I am going to do a AC supply. Okay. So to a diode. So what I am going to give us an input is AC supply, which means phase neutral. Okay. So here it is going to be my output voltage. Okay. So if I straightly give like this means, what about my diode? If my AC voltage is fluctuations, what happens? My diode will damage, right? So what will be doing? I will be connecting a to limit the current. I don't need to connect a resistor. Okay. So I will be connecting a resistor to it. Okay, so if I want to convert this AC to DC, or else we can connect in this way. Okay, so rectifier, two modes of operation. Okay, if this is phase and this is neutral, means it will become reverse bias condition, right? So we can draw this. Anode cathode. So phase to anode it will be
Forward.
forward bias condition. Okay, so I will tell you that. Okay, I will tell you that forward bias, reverse bias condition on that. But basically, what you want to know is this conversion. So what is happening when you are giving an AC as an input? What is like it is converting as DC. To limit the current for that purpose, we are adding a resistor to it. Okay, so this rectifier circuit is said to be the diode rectifier. Okay, and so now we know that diode has a two terminals, one is anode and other is cathode, and we know the specification for it. Likewise, so where we are applying this diode? Can you give me some application example? Small application example. I studied hardware rectifier. This studied it.
School level.
Okay, okay. Now tell me where they are applying it, diode rectifier.
Electronic devices.
Mostly probably that one has a specified application means one specified application for diode rectifier means
Cell phones.
okay, I will tell you. Okay, in serial bulbs. Okay, in serial bulbs, you might have seen that after connecting to the plate, a small box will be there. Did you notice that? After that only your bulb filters will be there, which is connected in series. Right? Am I right? Once connected to the plug, okay, so it's going to be a small box. Inside the box, what it will be there means you will be seeing that a rectifier circuit will be there. That is, okay, diodes are connected. If you notice that, the diode will be connected like this. The diode will be connected like this. Okay. So here is your input AC supply, and by then we will be having the not this one. By then we will be having the DC supply. Okay. So this diode rectifier circuit will be say I have connected it like this way, right? One after the other. Okay. So this is said to be the bridge diode rectifier. Okay. So in every serial bulb, if you open that box, inside that you can see the diodes. The diodes are connected in this way. Why they are using 4 diodes means actually what we want for serial bulb we have multiple bulbs has to do, right? So initially we are taking a 230 volt, right? So to make us serial bulbs to go low, do we need 230 volt? So what we will be doing?
Reduce the
First we have to step down it. Okay. So we will be using a step down transformer. I will show you that. Okay. So I told you, right? So here we are giving a input AC supply. So this is 230 volt. Okay. So 230 volt means you will be having a small transformer. Okay. So if you note down here, we will be writing it as 9 volt. 9 volt 09 volt. Likewise, the small transformer are available. 12 volt is available. 24 volt is available. Whatever for our requirement based on the electric devices which you are going to operate based on the transformer ratings are available. So whenever we are giving this is input, what is the function of a step down transformer? It will step down. You know that the conception of step down transformer. Primary windings are greater than the secondary winding. So based on the number of turns, it is going to transfer the electrical voltage. It will what it will do? It will step down the electrical voltage. So yeah, from the output of this, okay. Now here we will be getting the output from the transformer. Okay. So here the phase neutral. This is what AC only. Okay, just we are stepping down the AC voltage. That is 130 voltage. We have stepping down into 9 volt. If it is a 9 volt means 9. If you notice that here we have written as 9 volt 09 So it is stepping down to 9 volt AC. Okay. So from here also we will be taking a phase neutral of 9 volt. Okay. So after that we will be connecting rectifier, that is diode. Okay. So from here on to the next, what we are going to do? We are going to connect this. We will be giving it in breadboard. Okay. So after giving to breadboard means we will be connecting to breadboard the diode along with the resistor. For what purpose the resistor is? To limit the current. Okay. Because there won't be any damage for the diode. So to limit this current, we will be connecting the resistance in series to it. Okay. So after that, what happens? This diode will convert the particular AC to DC. That is how the diode rectifier will work. Okay. So now you have to write down the principle of operations of this diode. Actually, this is the concept. What it is doing. Okay. For writing the principle of operations of the diode, you must know the forward bias and reverse bias condition. Okay. So this is how, as I said, for the serial circuit application also, what it will do is using the bridge diode rectifier. Anyways, an AC supply that is connected to the diode means it will convert it into DC. Okay. So with that supply DC only, what it is doing, the serial bulbs are glowing. Right. So now, listen. Diode of two. One is forward bias from anode to cathode. Okay. So the other is from cathode to anode. So this is forward bias condition. Okay. This is reverse bias condition. Okay. So for that also we will be studying here VA characteristics of it. Mostly we will be using, we will study this in school. P type semiconductor, N type semiconductor. So we can say that PN junction diode. Mostly we will be using this. Then P type semiconductor, okay, is in junction with the N type semiconductor. In between who is there? Depletion layer is there. Okay. In between there will be depletion layer is there. Okay. So this is P type, or we can say this P type, and this is the terminal anode, and this is the N type. We can say the terminal as yes. So this is how PN junction diode with the junction depletion layer. Okay. And now two modes of operation will be there. Okay. First is forward bias condition. Okay. So the diode is going to be forward bias. Okay. So I am going to experimental setup. I am going for a battery. For the experimental setup, what we are going? I am going for a battery. Battery means we can say that regulated power supply. Okay, I can vary the voltage up to 0 to 30. Next, what will be there? Resistor will be there. After that, what will be there? Diode. If this positive is connected to anode means that is positive is connected to anode means that is no. That's it. So, here will be our output voltage. And this is cathode. So this is the forward bias diode function. So now, what we will be doing? Input as an input, we will be giving a DC. For experimental purpose, I have changed it. That is application oriented. Why we are using, why we are going for diode rectifier. For that purpose, I explained that. Okay, so experimentally study the diode rectifier. Diode rectifier மட்டும் பத்தி படிக்கிறதுக்கு we will be experimental setup யூஸ் பண்ணா படிப்போம். That experimental setup we are giving a DC. நான் அது வந்து ஒரு அப்ளிகேஷன் ஓரியன்டடா சொன்னேன். diode rectifier எங்க மேம் யூஸ் பண்ணாங்க அப்படினு கேக்கும்போது அப்ளிகேஷன் ஓரியன்டடா நீ டிவி பார்த்தா அப்படினா we are giving input as
DC.
DC.
Yes.
டிவி பிளக் எங்க கொடுக்குறோம்?
ஏசி சப்ளை.
ஏசி சப். ஓகே, பட் உள்ள இருக்கிற எலக்ட்ரானிக் டிவைசஸ் ஐட்டம்ஸ்லாம் இருக்கும், அவங்க பார்த்துக்கிட்டியா? உள்ள வந்து சிப் போர்ட்ஸ் இருக்கும், போர்ட்ஸ்ல என்ன இருக்கும்? சின்ன சின்ன எலக்ட்ரானிக் டிவைசஸ் இருக்குமா, கெப்பாசிட்டர்ஸ் இருக்கும், டயோட்ஸ் இருக்கும். ஓகே, ஆர்எல்ஸ் அதர் எலக்ட்ரானிக் ஸ்மால் டிவைசஸ் will be there. Everything will act in
டிசி.
DC. ஓகே, எல்லாத்துக்குமே வோல்டேஜ் ரேட்டிங்ஸ் எவ்வளோ? ரொம்ப மைனர். ஓகே, ஃபார் தட் we are going for that particular devices, for that we are going for that diode rectifier. அப்ளிகேஷன் அவங்க சொன்னதுதான் ஏசி. அதை நான் ஸ்டெப் டவுன் பண்ணிக்கிறேன் using a step down transformer and by using a diode rectifier I am converting it. ஓகேவா? so diode rectifier operation, whenever you are studying about specifically and want to know the operation of the diode rectifier means I will be going for the experimental circuit, not with the AC. AC வச்சு நம்ம டெஸ்ட் பண்ண மாட்டோம். AC வச்சு ஏன் பண்ண முடியாது? we have to further stepping down of voltage. okay, இங்க என்ன பண்ணிக்கலாம்? DC voltage நம்ம கொடுத்துக்கலாம். 30 voltage நம்ம ஃபிக்ஸடா, so அது diode rectifier எந்த voltage rating ல ஆட் ஆகுமோ that minimum value of voltage I can able to provide, right? so that is for a reason we are going for a DC. okay, so I am giving a DC supply, regulated DC power supply of rating 0 to 30 volt and can vary up to 30 volt. I am connecting a resistance of any value. Most probably you can choose it at 1 kilo ohm or 100 ohm. Okay, where between that very particular ranges. Next to is the diode. Okay, so the positive terminal that is connected to the anode, it is forward bias. Later on it will be decrease movement of current. Okay, so either at that point so what will happen means we will be seeing that as a characteristics. Voltage with respect to current. Okay, so this is during forward bias. This first quadrant we will be saying this is first quadrant, right? so this first quadrant will be seen as a forward bias and this is that quadrant we will be marking for the reverse bias. Okay, so how the conduction of the diode will be? Once the voltage is given, what is going to happen? We have to explain this diagram. Okay, once positive terminal is connected to the anode and the negative terminal is connected to the cathode, what will happen means here who is going to be there means holes. In p-type junction, who is going to be there? Holes. And in n-type, electrons will be there. And in n-type, who is going to be there? Electrons will be there. What will happen means, when the positive terminal is connected to the anode is connected to the positive terminal, and when the cathode is connected to the negative terminal, the holes from the p-type semiconductor and the electrons from the n-type semiconductor will move towards the depletion region. That is why I write the operation. What will happen? What you have to say? When the and the cathode is connected to the negative terminal, the holes from the p-type semiconductor and the electrons from the n-type semiconductor. Why it is electron? Negative electrons is n-type semiconductor. Okay, in p-type semiconductor it will be holes. Okay, both will be moved towards the depletion region. So what will happen? The depletion region will become narrow, slower. Okay, so when the depletion region is lower means what will happen? The conduction starts. Okay, so based on the voltage we are applying. Okay, based on the voltage we are applying, how the current. So if voltage increases automatically, current increases. This is how. That is the forward bias of the PN junction, or we can say the forward bias of the diode. Okay. So the next is reverse bias. For reverse bias, anode is connected to the negative terminal, cathode is connected to the positive terminal. And likewise here also, the same. Okay, anode is connected to the negative terminal and cathode is connected to the positive terminal. So during this time, what will happen is the holes from the p-type semiconductor, the holes from the p-type semiconductor will move away from the p-type semiconductor, and the electrons from the n-type semiconductor will move away from the depletion region. What you have to say? The anode is connected to the negative terminal, cathode is connected to the positive terminal. During this reverse bias condition, what is happening? The holes from the p-type semiconductor move away from the depletion region. Likewise, electrons from the n-type semiconductor moves away from the depletion region. So, what about the depletion region then? Broader, or we can say that is wider, higher in weight. So, at that time, what will be happening is it will basically, while the conduction during the positive of cycles, there will be some leakages, right? So, up to particular point, it will increase. Here, a small arrow that is used in the forward bias leakage. Okay. After that, what will happen means during reverse bias, there will be no increase of current. Here is also the same voltage, and this is current in reverse bias, voltage in reverse bias, this is voltage in forward bias, this is current in forward bias. Okay, so what will happen? Initially, due to some forward bias leakage condition, it will increase for some period. After that, there won't be any increase in current. After that second period, what will happen means it will occurs a breakdown. There occurs a what? Breakdown. Okay. So beyond that, what will happen means the current will increase drastically. The voltage changes. Okay. This is how the operation of the diode will be. What you have to say means during the reverse bias condition, with respect to the voltage, the current will remain same for some period of time. It won't change. After particular voltage rating, this voltage, this particular voltage breakdown. Okay. That breakdown period of that particular voltage is said to be breakdown voltage. That voltage and the breakdown attained on the time level, the current will get drastically increased, but your voltage won't change. In RPS we will be seeing it as an experiment also. Okay. In regulated power supply, if you take the input RPS 0 to 30 volt, in 15 volt if it is getting breakdown means if you are still increasing 16, 17, 18, still you are increasing, but what it will do means the voltage whatever you can increase, it won't, the current will increase. So, but the voltage cannot be changed. Okay, you can't be changed the voltage. That it will be fixed. Okay, and here it is increases, it increases. Okay, this is the characteristics of the diode. Okay, okay.